Hi dear student, this is Naveed Khan, your mathematics teacher. Today we will discuss system of linear equations by matrix method. In our previous class we had discussed a system of linear equation to solve system of linear equation 2 by 2 and 3 by 3 matrix by Cramer rule, but here we will discuss by matrix method. Okay, so let's have a look. For example, here we have a 2 by 2 matrix, the system of linear equation having two variable x and y. So here we have the first equation. So the first equation is 3x minus y is equal to 4. This is equation 1. And the second equation is x plus 2y is equal to 13. So this is the second equation. Now first of all we will write down the augmented matrix. So we will write down the coefficient of x and y. The coefficient of x is 3, the coefficient of y is minus 1, then here is 1 in the second equation, and then the coefficient of y is 2. Here x is equal to small x and small y, and the right hand side it will consider to be matrix B. Okay, so now it will become a x is equal to b, but we need the value of x. So x is equal to a inverse b. We know about it when we have ax is equal to b. Okay, so taking inverse on both sides, a inverse into a into x is equal to a inverse into b. Okay, so this a into a inverse, this is identity matrix. So now only we will here will be only x, and here will become a inverse b. Okay, so now in this step x is equal to a inverse b, and now x is equal to a inverse b is equal to adjoint of a divided by determinant of a into b. Actually a inverse is equal to adjoint of a and divided by determinant of a. Okay, so here it place of a inverse, I wrote here adjoint of a divided by determinant of a, and then multiply by b. Okay, so first of all, this is matrix A. We will find out the determinant of A. So determinant of A will become by cross multiplication. So 3 multiplied by 2 minus, and minus 1 multiplied by 1 multiplied by minus 1. So after calculation 6 plus 1, so the answer will become 7. So determinant of A, it will become 7. Here we need to find out the adjoint of A. So how to find out adjoint of A? Go to matrix A. This is matrix A. A is equal to 3 minus 1, 1 and 2. So now when I will find out adjoint of A, so it will become, now the diagonals, elements of the diagonal, it will be replaced with either. So 3 will be replaced by 2 and 2 will be replaced by 3, and the off diagonals element, the second diagonal, here the place of 3 and 2 will be changed, but in the second diagonal the sign will be changed. So this is minus 1, it will become plus 1, and this is plus 1, it will become minus 1. So this is adjoint of 2 by 2 matrix. Okay dear student, now this is determinant of A, and this is adjoint of A. So both the values we will put in the formula to find out the value of x. Okay, so here x is equal to, I wrote down this equation again, adjoint of A. In the previous slide we find our adjoint of A, so this is adjoint of A, this is the value of b, and then divided by 7, which is determinant of A. Okay, Now the first element, it will be multiplied with the first element, so 2 multiplied by 4 then plus, and the second element, it will be multiplied with the second element of the first column, so 1 multiplied by 13. Similarly the second element is minus 1, so minus 1 multiplied by 4, okay, then plus, and the second element, which is 3, it will be multiplied by 13. Okay, so after this calculation, 2 multiplied by 4 8, plus 13 multiplied by 1 13, and the second minus 4 plus 31, and then divided by 7. Okay, so now 13 plus 8, the answer is 21, and 39 minus 4, the answer is 35, and then divided by 7. Now divide each term, each number by 7. 21 by 7, and then 35 by 7. Okay, so the final answer which we have is 21 by 7 is equal to 3, and 35 by 7 is equal to 5. Okay, so now capital X is equal to 3 and 5, so the value of the small x, this is small x. Okay, small x is equal to 3 and small y is equal to 5. Okay, so thank you very much, my dear student. This is the system of linear equation having two variables x and y. How to solve this system of linear equation by matrix method. Okay, so thank you very much, my dear student.